Hi friends, welcome to Engineers and You. In this video, we are going to discuss one-dimensional displacement function for two-node linear element. So, displacement function for one-dimensional two-node element. The other name for one-dimensional two-node element is linear element, two-node linear element, or two-node bar element. These are the other names for one-dimensional two-node element, that is two-node linear element and two-node bar element, right? So now just before starting this one, we will formally discuss the one-dimensional element, then we will go for the displacement function. So one-dimensional element means it's basically one dimension is a linear element. It's when the body is discretized into geometrical shapes, no geometrical shapes, it will be in terms of one-dimensional element, that is just like a lines. So one-dimensional linear elements consists of two nodes, that is node 1 and node 2. Now, in order to describe the locations of two nodes, we are going to take some coordinate system. So for this one, we are going to consider the Cartesian coordinate system, taking the origin. So that is here, and it is at a distance x1 because it is a one-dimensional. The other node is at distance x2. Now, if you want to find any location on the element, we are going to consider that one as x. So, the displacement function, when the load is applied on the body, when the body is discretized into one-dimensional load, the body will get elongated. So definitely there will be some deformation will be there. So how much quantity of deformation, that if you want to expect, means we have to provide the assumption what type of displacement function, how the displacement function will be. So how the deformation will be. If you want to express mathematically, so we are going to consider some mathematical function for describing the displacement the load is applied. So assuming the displacement follows linear function. So that is u is the displacement. If you consider, it is following a linear function. So that is a0 plus a1x. This is the displacement function. So if you want to find the displacement at any location, you just substitute the x on the body, then we can able to find the displacement at a particular location. Suppose this is the equation A. Because this is the equation, but in this equation there are two constants, a0 and a1. What is a0 and a1? We don't have any meaningful information, and we can't able to describe how the deformation going to affect. We can't able to predict how these deformations is going to affected by the constants a0 and a1. So in one form we can say displacement follows linear function, but what is a0 and a1 we don't know, and what is the effect of these constants on the displacement also we don't know exactly. So to make this equation as meaningful form, I am rewriting this equation in terms of the nodal displacements. So nodal displacement is the displacement we are going to consider at node 1, what is the displacement at node 2, then by correlating that one we can able to find the displacement at any point. Suppose the nodal displacements, the displacement at node 1 is u1. Similarly, the displacement at node 2 is u2, and u1 and u2 are the nodal displacements. u1 and u2, and u1 u2 are the nodal displacement. So in order to rewrite the equation in a meaningful form, what I am doing is I am calculating the u1 by substituting the x1. That is, u1 is available at a location x1. So u1 is equal to a0 plus a1 x1. Similarly, u2 equal to nodal displacement at 2 equal to same equation a0 plus a1 x2. So suppose that this is the equation B and this is the equation C. Now these two equations, because we have to find out what is a0 and a1, and we have to rewrite the basic displacement function in terms of the nodal displacement values, that is u1 and u2, because if you want to we want to make this one a meaningful function. So what I am doing is, because we have two unknowns a0, a1, and we have two equations, we can solve and we can able to calculate what is a0 and a1. So in order to calculate this one, a0 and a1, we are solving equations P and C. So when you are solving the equations, u1 equal to a0 plus a1 x1, u2 equal, we'll take u2, and this is x2, u1 equal to a0 plus a1 x1. Now we will write. So these two will be cancelled, that is u2 minus u1 equal to a1 into x2 minus x1 we can write. What is a1? a1 equal to u2 minus u1 by x2 minus x1 we can write. What is x2 minus x1? Here the difference of the x1 and x2 will represent the length of the element. That is x2 minus x1 we can consider almost equal to length. So you can rewrite u2 minus u1 by x2 minus x1. In place of x2 minus x1 you can put length of the element. That way also we can write. So this is the a1. Now we have one constant a1. What is a1 means? Now by substituting the a1 value in any one of the B and C equations, then we can able to find out the what is the a value, a0 value. So substituting, we are going to calculate substituting a1 in equation B, suppose C. Then u1 equal to a0 plus, what is a1? u2 minus u1 by x2 minus x1 into x1. So now I can simplify this one. What is a0? a0 equal to u1 minus u2 minus u1 by x2 minus x1 into x1. I can further simplify this one, that is x2 minus x1, that is u1 x2 minus u1 x1 minus of u2, that is this one, u2 x1 plus u1 x1 by this particular x2 minus x1. Now you can simplify this one, minus u1 x1 plus u1 x1, these two will be cancelled, and from this one we can rewrite what is a0 means. So u1 x2 minus u2 x1 by x2 minus x1. So now we have two unknowns, that is what is a0 and what is a1. This is the a1, this is the a0. By substituting the a0 and a1 in the basic equation A, then we can able to find the displacement function in terms of the nodal displacement, that is u1 and u2. So now I am substituting a0, a1 in equation A. So substituting So that is A0 and A1 in equation A. Then what is the u displacement function? U equal to A0. A0 is u1 x2 minus u2 x1 by x2 minus x1 plus then A1. What is A1? u2 minus u1 by x2 minus x1 into x. Now I am further simplifying this. That is u equal to x2 minus x1 is a common, and we can substitute, you can eliminate u1, u2, you can simplify u1, u2, u2 x1, u1 x2 minus u2 x1 plus u2 x minus u1 x. Now what I am doing is I am taking the u terms one side, u1 terms one side and u2 terms one side, and rewriting in the equation form. That is u equal to, first we will take u1 outside, that is u1 x2, and this is what else, u1. So this one, so that is x2 minus x, that is x2 minus x into u1 plus what else here, this one, x minus x1 into u2, you can write by, so you can separate this, x2 minus x1 by x2 minus x1, you can, because we are separating that one, so each one is divided by x2 minus x1, x2 minus x1. Now I will rewrite this equation instead of this, because here the equation function, the displacement function is available in terms of a nodal displacement u1 and u2, and there are some constants like x2 minus xy, x2 minus x1, x minus x1 by x2 minus x1. So I am rewriting this one. So u equal to n1 u1 plus n2 u2. So where n1 equal to x2 minus x by x2 minus x1. This is the one, and the second one is n2 equal to, what is n2? X minus x1 by x2 minus x1. This n1 and n2 is known as shape functions, are known as shape functions. n1 and n2 are known as shape functions. So with these functions, now the displacement function is written in terms of shape functions, that is the nodal displacement u, that is n1 u1 plus n2 u2. So this particular equation, now it is written in terms of the nodal displacement, that is u equal to n1 u1 plus n2 u2. So in this equation, what is a0, a1? We don't have any meaningful information. Now the same function we have written in terms of the nodal displacement, that is n1 u1 plus n2 u2, where n1 and n2 are nodal the shape functions, and u1 and u2 are the nodal displacements. What these shape functions will define? So the from the the displacement is nodal value, nodal displacements, we can able to predict the displacement at any location x, just by substituting the x2, x1 values, that is by default is available. And if you know the nodal displacement, what is the displacement at u1, so node 1, and what is the displacement at node 2, you can able to predict displacement at x location. That's what these equations. So these the shape functions will define the shape of the curve as well as the displacement. We can able to calculate any locations. So that is a meaningful form. So here we have described this one, the locations of the element in the Cartesian coordinate system. So the shape functions here, it is available in terms of the Cartesian coordinate system. Suppose if you define this one in the natural coordinate system. What is a natural coordinate system? A coordinate system is one in which the origin of the body lies within the body itself, and the value ranges from -1 to +1. So the type of coordinate system is represented with the coordinate system is known as natural coordinate system. So if you have any further clarification about the natural coordinate system, please visit my previous video. Please see my previous videos so that we can clarify what is a natural coordinate system. Now let us see the displacement function in terms of the natural coordinates. This is the displacement function in terms of the Cartesian coordinate system. The same functions, same equation, I am going to rewrite in terms of the natural coordinate systems. In the natural coordinate system, I am rewriting this diagram. So this is the element having the node 1 and node 2. So in the Cartesian coordinate system, it is x1, this is at x2. This is the Cartesian coordinate system. Now if you want to find any location, this is at x location. If you want to find any point on the body, we can consider at any x location. Now in the Cartesian coordinate system, in the natural coordinate system, x is at any location is represented with a xi. X is represented with xi, and the leftmost corner, that is it ranges from -1 to +1. That is xi equal to -1 here and xi equal to +1 here. At node 1, that is x equal to x1 and that is xi equal to -1. At x equal to x2, that is at node 2, xi equal to +1. If you want to find the displacement at any location, that is x. So here x represents the xi and xi represents at x equal to x1, xi equal to -1. At x equal to x2, that is a node 2, xi equal to +1. Okay, now is just to substitute in place of in the shape functions, that is in the Cartesian coordinate system, x2 minus x by x2 minus x1, and in terms of the natural coordinates, that is xi. So n1 equal to x2 value is +1, x value is xi, 1 minus xi by x2 minus x1. x2 is +1 minus of x1, at x1 xi value is minus of -1, that is 1 minus xi by 2. Okay, so n2 the Cartesian coordinates, it is x minus x1 by x2 minus x1. In the same way, you can rewrite this one in the natural coordinates, that is 1 xi, that is in place of x is just substitute xi, in place of x1 we can substitute -1. Xi value is -1 by 1 minus of -1, that is 1 plus xi by 2. So this is the shape function n1, this is the shape function n2 in the natural coordinates, in terms of natural coordinates. In terms of natural coordinates, that is n1 equal to 1 minus xi by 2, n2 equal to 1 plus xi by 2. So here the displacement function is same as usual, n1 u1 plus n2 u2. Same equation, if you consider in terms of natural coordinates, then n equal to 1 minus xi by 2. If you want to consider that is n2, then 1 plus xi by 2. So in case of natural, this Cartesian coordinate system, x1 equal n1 equal to x2 minus x by x2 minus x1, n2 equal to x minus x1 by x2 minus x1. This is the displacement function in terms of the natural coordinates and in the Cartesian coordinates. This is all about today's lecture. And if you like this video, please share.